Hello, this is Mrs. Lim, your physics teacher. Okay, in this section of the radioactivity video, we will be covering about what are nuclear fission and nuclear fusion. Okay, so we will be covering what exactly is happening during nuclear fission as well as nuclear fusion and relate all these nuclear processes to the release of energy from nuclear fuel and how it's used in nuclear power plant. So let's go into it. The first one is nuclear fission. Okay, fission is actually splitting up. Fusion is actually combining. You fuse two things together, means you combine them together, while fission is splitting up. Okay, I'll go into nuclear fission first. This is the definition of nuclear fission. Nuclear fission is a process in which the nucleus of an atom splits up. Okay, it can be split up into multiple parts, but for nuclear fission is usually split into two parts. And in the process of splitting up, it releases a huge amount of energy. And this energy is usually converted into the internal store as heat energy. Okay, so basically the diagram looks like this. Okay, you have the neutron. Okay, a neutron will collide with a radioactive substance. Okay, and in our nuclear power plant, we usually use uranium 92. Okay, looks like this. So the neutron hits it, okay, and it will start to become unstable and it will split itself up into two, what we call daughter nuclei. Okay, split out itself into two smaller nuclei. Okay, and in the process of splitting up into two smaller nuclei, it also releases neutrons. Okay, these two smaller nuclei are this one, Kr and Ba. Okay, Kr and Ba. And in the process, it also gives out neutrons. This given out neutrons, it will in fact give out two neutrons over here. These neutrons will then continue to collide with the other uranium inside the reactor. And then the process goes on and on and on. Then after that, a lot of uranium is all converted into Kr and Ba. And the neutrons that's given out will continue to collide with more uranium. And the process just goes on and on and on. And this whole process releases a large amount of energy. There are certain terms that you need to know. Okay, the original atom is actually called the parent nucleus. And after that, they got split up. They don't just emit radiations like alpha, beta, gamma. Okay, they splits up into two smaller atoms, which is called the daughter nuclei. So the parent nucleus decay to form two daughter nuclei in this case. And then the daughter nuclei may be stable or may be unstable. If it's unstable, it will continue to further decay and release more energy. If it's stable, then it will just remain as it is. Okay, so there are several possible fission products. Okay, you do not need to memorize this. The question will tell you that it's being decayed into what substance. So you don't need to memorize this. You just need to know the before it split up, it's called the parent one, and after it splits up to form the smaller nuclei, it's called the daughter nuclei. So this is the parent nuclei. Okay, it got hit by one neutron and then it will start to decay, okay, and to become or split up into two nuclei, which is Ba and Kr. And in the process, also three other neutrons are released. So you need to, they will tell you what are the substance that is being formed, okay, but sometimes they may ask you to fill in the atomic number and nucleon number to balance the entire equation. So just take note again, the total number of protons or atomic number must be the same on both sides of the equation, similarly for the nucleon number. Okay, so this is a diagram that looks like this. So the neutron hits the uranium, split up into two daughter nuclei, Kr and Ba, which also gives out neutron. This further neutron again hit the next uranium and then splits up again. And this entire thing is a self-sustaining chain. No extra energy are needed. It will automatically happen non-stop as long as one nucleus hits one uranium, the entire process will just continue and continue and continue and continue forever. So it's called the nuclear fuel cycle. It's a self-sustaining chain. Nothing needs to be done. Okay, so what happens to the energy changes during nuclear fuel? So in the process of splitting up, energy is transferred from the nuclear store of the unstable nucleus, okay, into the kinetic and internal and nuclear store of the daughter nuclei, as well as the neutrons. Okay, the neutrons will be emitted out with kinetic energy. Okay, then the next neutron will then hit and collide with the next parent nuclei. Okay, so in the process, a large amount of internal stores is being released as well and is channeled to the surrounding as heat. And then how do we use it in the generation of electric power? Instead of using fuels, fossil fuels, you use fossil fuels to burn, to generate heat or to generate steam. Okay, to turn the turbines, we are using this kind of reaction, nuclear fission reactions, to generate a lot of heat. This heat is then used to but, produce steam, and then the steam is then used to turn the turbine to generate electricity. So these are examples of nuclear power plants. Okay, then we move on to the next type. I'm not going to play the video. You can watch the video yourself. The next type of reaction is nuclear fusion reaction. Nuclear fusion, from the word fusion, means two smaller atoms combined to form a bigger atom. So the exact definition of nuclear fusion is as follows. Nuclear fusion is a process in which two small or light atomic nuclei combine to form a bigger and heavier atomic nucleus. And in the process, it also releases a large amount of energy. Okay, so you can see hydrogen 2, hydrogen 3 combined together to give you a helium nucleus together with one neutron. Two smaller one, H, hydrogen, becomes a bigger one, helium. Okay, one very good thing about nuclear fusion is you will realize that they uses mainly unreactive or very safe substances compared to uranium. Okay, they just use isotopes of hydrogen, etc. So nuclear fusion is actually a much safer process than nuclear fission to generate a large amount of heat. But, okay, there is, so the same thing happens that during nuclear fusion, energy is transferred from nuclear store of the two nuclei to the kinetic internal and nuclear store of the bigger nucleus, as well as the internal stores of the surrounding. Okay, but although nuclear fusion is much better than nuclear fission because it doesn't really use highly radioactive substance like uranium, we are sad to say that we are unable to produce much nuclear fusion reaction on Earth for now. Okay, so what happens for nuclear fusion to happen? Okay, you need to understand that the nucleus of atoms are usually positive charged. It contains protons and neutrons. There's no electrons, so they are positively charged. In order to force two nuclei to come together, it is very difficult because they are both positive charge. You know, positive charge and positive charge will repel each other. So a lot of work needs to be done to overcome these repulsive forces between the nuclei during the nuclear fusion. As a result, nuclear fusion requires very high temperature and very high pressure. And sad to say that we cannot produce that amount of high temperature and pressure in order to force that two positively charged nucleus to come together on Earth much. Okay, so it's currently not used in nuclear power plant. In order to get them to fuse together, too high temperature and pressure is required. Okay, but scientists are actually working on it, which I'll talk about it later. So where does nuclear fusion happens? It takes place in the sun because in the sun the temperature is super high and the pressure is super high, and it's just continuously burning and burning and burning because at the same for nuclear fusion and fission, the process is self-sustaining. It will just goes on and on and on, and that's why the sun in the sun it keeps burning and the sun keeps giving out heat non-stop. Okay, so a lot of research, government is pumping in a lot of money and a lot of research to see whether we can uh, create certain conditions for the nuclear fusion to take place to fuse that two nuclei together. If we can actually do it in our nuclear power plants. So they are trying to work on reactors. So to create a safe and controlled manner, uh, to create energy to change the water into steam instead of using nuclear fission that always needs to use uranium, which is highly radioactive. Okay. Okay, I will not show you this video, but you can take a look at this video yourself. So that's it for nuclear fusion and nuclear fission.